All right, welcome to page 3. It's the last page of the new notes today. Again, today's not going to take too long if you're just working through section 12.1. And what we're going to talk about now is the equation of a sphere. And so it lends itself very well in the three-dimensional coordinate system from the equation of a circle. Again, if you recall, in past classes in the two-dimensional coordinate system, this would give us our circle where h and k is going to be the center. And now, since we're in the three-dimensional coordinate system, we add in our z's, and so therefore now instead of having a circle, we have a sphere that is going to be created by this equation. Again, the radius is going to be r, and if our center is at the origin, therefore h, k, and l are going to be 0, then our equation for a circle is going to be x plus y squared plus z squared equals r squared, if it's at the center. All right, so we're going to find an equation of the sphere with center 2, -6, 4, and radius r, and we're going to describe its intersection with each of the coordinate planes. And so I'm going to zoom in a little bit just so that we can create some space. And the first thing we do is we're going to write the equation of a sphere. So we have all of our values, h, k, and l. And I'm just going to go ahead and substitute those into our equation. So we have x minus 2 squared plus y minus a -6, so y plus 6 squared, and plus z minus 4 squared. And that's going to equal our radius 5. So 5 squared is just 25. So there's our equation of a circle. All right. And now what we're going to do is we're going to describe the intersection with each of the coordinate planes. And so our coordinate planes are going to be the xy plane, the xz plane, and the yz plane. So the first plane that we're going to use is the xy plane. Now, when our when our sphere intersects the xy plane, what that means is that z is equal to 0. So all what we need to do is substitute in z equals 0 into our sphere equation, and we're going to be able to determine what the intersection looks like with the coordinate plane. Since this is a sphere, when it intersects, the xy plane, what's going to be created is just going to be a circle. And so when we substitute in our value z equals 0, we're going to get x minus 2 squared plus y plus 6 squared plus 0 minus 4 squared equals 25. And then we're going to do some math. We'll get x minus 2 squared plus y plus 6 squared. -4 squared gives us 16. So we're going to take away, since this gives us a positive 16, in order to find our circle, we're going to subtract 16 from both sides. So when we subtract 16 from both sides, I'll change the color so you can see that this is what our circle is going to be. X minus 2 squared plus y plus 6 squared equals 9. And so therefore, the intersection of the xy plane is is a circle with center 2 negative 6 with radius 3. Square root of 9 is 3. All right, so that's the first one. And then we'll just do the same. Now, one thing that I want to note is the next one. So the next plane that we're going to look at is going to be, instead of doing the XY plane, let's do the YZ plane next. So YZ plane. So in order to do the YZ plane, x has to equal 0. And so we're going to do the same thing. I'm going to do this one a little bit faster. And so when we substitute in, we're going to have 0 minus 2 squared plus y plus 6 squared z minus 4 squared. And that's going to equal 25. So, and solve, so 0 minus 2 is negative 2. So we square the negative 2, we get 4. So this right here becomes 4, and we're going to subtract 4. And so we're just going to get 21. So our circle equation is going to be y plus 6 squared plus z minus 4 squared equals 21. So the intersection of the YZ plane is a circle with center at 0, negative 6, 4. And I should have included 0 down here. So I'm going to do that real fast. Oh, that was too much. And radius square root of 21. And again, that's what I want the solution to be. All right, now the last one we're going to do is the, let's use black, is the XY, YZ, so we need the YZ plane. I'm sorry, the XZ plane. Write that a little bit better. It's the XZ plane. And so the XZ plane is where y is going to equal 0. Now, what you can do is you can go ahead and plug into the actual formula, and I'm going to do that, but you can go ahead and say it's not going to intersect the XZ plane. And how do we know it's not going to intersect the XZ plane? Well, if our radius is 5, and we're up at, positive 6 on the y, that distance, that point at 6, means that our sphere is never going to intersect the YZ plane, the XZ plane. So therefore, I could go ahead and say no intersection. And again, the reason for that is saying y plus 6 and radius 5. All right, because my radius is 5, I'm not going to intersect the xz plane. Again, you can substitute in your values, but if you did substitute in your values, I'll do that real quick. X minus 2 squared plus 0 plus 6 squared plus z minus 4 equals 25. And then we get 36, and we subtract 36, we would be left with x minus 2 squared plus z minus 4 squared equals negative 9. Therefore, we're not going to, we'll have a radius, we'll take the, square root of that, and again, we can't take the square root of a negative value. So therefore, that would also be able to help you tell that there's not going to be an intersection. All right. Example 5, show that the equation represents a sphere and find its center and radius. And so here we have an equation, x squared plus y squared plus c squared plus 8x minus 6y plus 2z plus 17 equals 0. The first thing that I'm going to do is I'm going to go ahead and rewrite the equation. And I'm going to go ahead and say x squared plus 8x plus y squared minus 6y. I'm going to group all my x's and all my y's and all my z's together. Plus z squared plus 2z equals, and I'm going to move that plus 17 over to the right-hand side. It's just easier to work with, and I'll show you why in a second. Now, what we want to do is we want to be able to write these in terms of, perfect, square binomials. And so in order to do that, we're going to complete the square. And so in order to complete the square, remember, you take, if things were in terms of ax squared plus bx, you take your coefficient with your x value, you divide it by 2, and you square it, and that's going to be the value that you need to add to be able to complete the square. So that's what we're going to do. 8 divided by 2 is 4, and then we need to square that, so we would need a 16 there. Over here, we have minus 6 is our coefficient with y, so negative 6 divided by 2 is negative 3. Square that. So we need a positive 9, so we need to add 9. And then for 2 divided by 2 is 1. 1 squared is going to be 1, so we need to add 1. And so in total, we need to add 16, 9, and 1 to the left-hand side. So because I moved 17 over to the right, all I need to do to balance this equation is now I'm going to add 16, I'm going to add 9, and I'm going to add 1 to the right-hand side. So now I have an equation that looks like this. X squared plus 8x plus 16 plus y squared minus 6y plus 9, then plus z squared plus 2z plus 1 equals a positive 9. And now what I can do is I can go ahead and factor this into x plus 4 squared. I can go ahead and factor my y's now to be plus y minus, it's always going to take on the value that's in front of your middle term. So y minus 3 squared. And then I can factor the z, which is going to be z plus 1 squared. And that's going to equal 9. So now I can find the center and radius. So my center is going to be negative 4, 3, negative 1, and my radius is going to be 3. And that's it. And so there again is my solution. So I'll highlight that so you know where to find the solution when you're looking at the notes. All right. Again, if you have any questions, ask me during class, and I'll be able to better explain it if you need it to be better explained. Again, you're going to have homework problems that you're going to work on that are very similar to this. And you can ask questions on those as well. So 2 more examples and we're done. Find an equation of a sphere if one of its diameters has endpoints 2, 1, 4, and 4, 3, 10. So we're going to find our sphere. It gives us the diameter, and what we're going to do is we need to find not only the radius, but we also need to find the center. And so in order to find the center, we're going to use the midpoint formulas. And so I'll write that here because I don't believe the midpoint yet. The midpoint's not given on these notes, but it's the same way of finding the midpoint in geometry when you first learned it. And it's going to be x sub 1 plus x sub 2 divided by 2. That's how we can find the midpoint of our x's. Y sub 1 plus y sub 2 over 2. And z sub 1 plus z sub 2 over 2. And so this is how we're going to find the center. And so our center is going to be 2 plus 4 divided by 2, 1 plus 3 divided by 2, and 4 plus 10 divided by 2. So that gives us a center of 6 divided by 2 is 3, 4 divided by 2 is 2, and 14 divided by 2 is 7. So we have a center of 3, 2, 7. Now we need to find the radius. So what we're going to do is we're just going to find the distance between these 2 points. I'll call this, I'll say that this is point A and this is point B, just so that you can see, mathematically what I'm doing is finding the distance between A and B. So, again, I'm just going to use the distance formula, and I'm going to have 2 minus 4. I'll do 4 minus 2. Again, it's not going to matter just as long as you keep the order the same. So 4 minus 2 squared plus 3 minus 1 squared plus 10 minus 4 squared. And we get 4 minus 2 is 2, so 2 squared is 4. So square root of 4 plus 3 minus 1 is 2. Square of that is 4. 10 minus 4 is 6. Square of that is going to be 36. And so we're going to have 4 plus 4 plus 36, which is going to give us 44. So we have the square root of 44. So that means that is our diameter. We can simplify this to be 2 square roots of 11, because 4 times 11 is 44. Square root of 4 is 2. So therefore our radius, just divide our diameter by 2, is going to be the square root of 11. And so there's our answer for that. And then finally, on the last part of the notes, describe the surface in 3-dimensional space. X squared plus y squared equals 1. I'm going to go ahead and draw this. You're not going to have to draw this, but I'm going to show you what this looks like. And if you ever want to draw it instead of having to write out what, if you do not like, having to write out all these words, it's fine. Just go ahead and draw it. And so that's what I'm going to do, just so you have 2 ways of seeing this. So again, I'm going to draw a 3-dimensional coordinate system, X, Y, and z. And here what we have is we have an equation in two variables when we put it in the three-dimensional coordinate system. So this gives us the equation of a circle with a radius, with the center is going to be at the origin, and we have a radius of 1. So basically we have a circle, and again, the drawing is not going to be perfect, at the center of the coordinate system, and we have a radius of 1. And so I'm just going to go ahead and draw a circle with radius 1. The problem here is that z is not defined. If z was defined, say z was equal to 3, we would just bump this circle up, 3 units, and we would be finished. But z is not defined. So therefore, z can be any, real number that's possible, because we're doing this on the coordinate plane. So because z can be basically any value possible, what we're going to have is we're going to have a circular cylinder that, is going to go up and down infinitely. So that's what we have. And notice that all it is going to be just the parts where x squared plus y squared equals 1. So there's no values inside or outside this circle. All right, it's just going to be the circumference, and it can be any value for z as long as x squared plus y squared equals 1. So that's what we have, a circular cylinder. And so here, instead of having for you to wait for me to write all of this out, I have it here. You can pause it. You can write this down. I'll just read it. So here you have x squared plus y squared equals 1 and no restrictions on z. So a point in the region must lie on a circle of radius 1. And the center is on the z-axis, but it could be any vertical plane on z equals k. Parallel to the xy plane. Thus, the region consists of all possible circles, x squared plus y squared equals 1, where z is any k. Z is a constant. Z can be anything. And is therefore a circular cylinder with radius 1 whose axis is the z-axis. So, again, if you want to write this in terms, so I ask you to describe the surface, all you would have to write down is this: a circular cylinder with radius 1 whose x-axis is the z-axis. That's all I would ask you to have to write. You don't have to write everything there. All right, and that does it for the notes. I hope y'all enjoyed the first day's worth of notes. Again, ask any question that you have once you've completed this, and as